introduction, so David, over to you. Hello.
Thank you very much. So I'm just pausing while people come and sit down. Hopefully you can hear okay online. If not, just put something in the chat and we'll try and sort it out. Well, I'd like to add my welcome to Slobodden. You don't normally welcome people as a visiting speaker, but I'm not a visiting speaker. I'm native. I live here. So welcome to you all. Also welcome to folk logging in online as well. And what I'd like to talk about today is the overall topic of wastewater pollution and public health, and its influence on public health. And in particular to look at engineering solutions and policy recommendations. I think possibly this is not so.
Just tell it on the screen.
Yeah. No, it could never be that easy. No. Apologies, we'll get there eventually. It goes. So here's a quick outline of what I'd like to talk about today. Start with an introduction, then to talk about the aim of the project that I'm going to be describing to you today, to look at the context and scope of the work, then to get into the methodology, how we did it, to look at some of the outcomes then, the interventions that we looked at in detail, followed by what were our recommendations, which was the idea of this project. And then in terms of an aspect that we don't often discuss in these technical types of presentations, engagement, and the influence that this sort of work can have, or could have, or should have, and then some brief final conclusions. So by way of introduction then, let me ask the question, why are we concerned about wastewater and public health? I think there's a whole raft of different reasons for that, but here's some of them. We have a growing population, we have developing urbanisation, we have intra-urbanisation, in other words, urban creep going on. We have the impacts of climate change, we'll go into those, we all know what they are. I think, frankly, we have overloaded and therefore now under capacity wastewater assets in places. And in combination with that, we have the popularity of open water recreation, which is not an issue that most of us in wastewater engineering think about or have thought about historically or traditionally. So there is this increased exposure then of the public to wastewater pollution. Two things that were traditionally kept, or ideally kept, completely apart. And that has led, this increasing exposure and interest has led to changing public expectations. What does the public expect about its wastewater system? When I started in the business, nobody cared tuppence about what happened to their wastewater. Now it's on the news every other day. You see those sorts of headlines I've shown there. So there is this greater public awareness of water quality, of the issue of pollution. There are complaints to water companies, for example, in terms of their performance. And there is this rather general loss of trust, I think, in the whole water sector, frankly. And then reported health concerns. And what are the links between health concerns and the wastewater system itself? So that sort of kicks off this work. That sets the scene for this work. What is the aim of the project? Well, the project and the report that we produced as part of the project was instigated by the National Engineering Policy Centre. And it was instigated by the National Engineering Policy Centre in discussion with the Chief Medical Officer for England. The Chief Medical Officer for England is Professor Sir Chris Whitty. Those of you that were in the UK during COVID will be very familiar with that face there, because Chris Whitty was on our television screens daily almost, giving us, I thought, credible, evidence-based advice what to do. I thought he acquitted himself very, very well. Still in post as the Chief Medical Officer for England, and he has a concern in his role about public health, recreation and pollution. And so in discussion with the NEPC, asked us the NEPC to examine interventions, doing things, available to reduce public health risk for people using public waters for recreation that may be polluted with faecal organisms from human waste. That was the brief. So he asked if we could do that report, came to the Royal Academy of Engineering to do that, and then to make policy recommendations to key stakeholders. So the first bit of the job is something we're perhaps more familiar with as engineers. The second bit of the job is something that is different, certainly different from my experience, and really why I'm talking to you today about this. To what extent can we make policy recommendations, and to what extent are they useful? In case you don't know, and I have to admit I did not know, what is the National Engineering Policy Centre? It is a unified voice for the 42 professional engineering organisations. It says something that we have 42 organisations, so getting a common voice is difficult, but the NEPC is one way of doing that, and that is resourced by the Royal Academy of Engineering. And to quote them, the NEPC, it brings engineering thinking to the heart of policy making, creating positive impacts for society, which is a great thing to do. And this type of work that we're talking about today really fits very, very much, fair and square, into that aim of the centre. Moving on now to the context of the work. Before we get on to the nasty stuff, the risks, what about the benefits? And there are rather wonderful health benefits of open water swimming, open water sports, and so on. There's a big literature on that, which I won't even attempt to go through today, but it broadly breaks down into physical, mental, and social benefits. So on the physical side, open water swimming, for example, can give you a really good workout, and yet your body is supported by the water. So rather less individual stress on joints and muscles and so on. And it's been evidenced to provide good improvements to your cardiac function, therefore blood circulation, oxygen transfer, and so on. And then there's the mental health side of things. I think leading from a reduction in blood pressure, it can, depending on how strenuous it is, slow your breathing, reduces anxiety, even been known or been reported to improve improve sleep. And then there are social issues as well. Quite often these are people swim or have sports together, so it brings opportunity for exploration, for adventure together. So all these things. So I think from a health point of view, there are lots of ticks. And that's probably why it is such a popular thing, and seemingly increasingly popular as well. Now that's the credit side of the balance. Now the debit side. What about the health risks? And I'm talking now about open waters that are potentially contaminated by, or influenced by wastewater. The health risks. The health risk that the Chief Medical Officer was mostly concerned about were the fecal oral diseases, and I think hopefully everybody knows what fecal oral means, and if they don't, they can probably guess what it means. Typically, fecal oral diseases in developed countries anyway lead to gastroenteritis and the symptoms. And again, you probably know what the main symptoms are of gastroenteritis. Typically diarrhea and vomiting. very, very, very unpleasant and can be dangerous in the extreme case. But there are also reported cases of eye infections, of skin irritations, ear, nose and throat, and even some respiratory illnesses have been attributed to contact with wastewater. And then there is the kind of secondary issue about antimicrobial resistance being developed in the wastewater system and put into the environment. We won't go into that in any detail today, but it is an emerging and important topic, actually. And then if you look at the research, and there's quite a lot of it, not a massive amount, but quite a lot, the conclusion is that rates, as a group, as a population, rates of some adverse health outcomes are higher in swimmers compared with non-swimmers. So you have to read that carefully. Rates of some adverse health outcomes. So that's not saying I swam there, I ingested that, I got sick. It's not that. It's looking more on a population level. One of the issues is how difficult it is to pin it down to an individual, actually. So continuing with the context side of things then, how do we currently manage, if I can put it this way, our contact in open waters with wastewater? And we currently manage it by complying with bathing water quality standards. These bathing water quality standards were developed in the Bathing Water Quality Directive, which is an EU directive, back in 2006. When the UK left the European Union, they were transferred into regulations in British law, so they are identical to the original directive. And these are the standards that are currently in play in our designated bathing waters. The waters can be identified as either inland or coastal, transitional. The parameters that we use, so-called fecal indicator organisms, are intestinal enterococci and Escherichia coli, E. coli. Both of those groups of microorganisms are highly numerous in mammals, in the guts of mammals. So if mammals are defecating, then they will be present. They will be present. However, those are microorganisms mostly don't cause disease. They're not pathogenic. There is an exception that a certain strain of E. coli is pathogenic, which has emerged since the standards were developed, I think it's true to say, or at least in common knowledge, common experience. But basically we can assume that they are not pathogenic, but they indicate there may be pathogens in the water. And then you can see the different levels of different standards measured in CFU per 100 mil. CFU is colony forming unit, and that is to do with the way that these microorganisms are tested. You grow them and you can count the number of colonies formed by individual bacteria. And you'll see they're then classified in excellent, good, sufficient, and then rubbish, no, poor on the end of that. I won't go into the detail, but these are percentile standards, so they're 95 percentile. So they're not means, they're percentiles. Quite handily for this presentation, the 2024 results of classification of all the bathing waters in England were published a week ago. I took this slide from the BBC, which I think gives a pretty good overview of where we are in terms of bathing waters in the UK, or in England specifically here. 450 sites there are designated bathing waters, and you can see through from 2016 to 24 with a gap in the COVID year. And then the purple are those water bodies classified as excellent, green is good, blue is sufficient, and red is poor. There's been a little bit of negative reaction to 2024 results because the red has gone up. You can see that there, it's gone up. However, this year there are 27 new designated bathing waters, so they only have a very short record of testing, and also new sites typically are not at the excellent status when they start. It takes time for interventions to take place to improve water quality. So I think at least something like half of those are poor before they even start. Hence, it's pushed the poor level up. Nevertheless, it is a concern, isn't it, that the red seems to be creeping upwards. So we need to keep a very, very close eye on that. The scope of our work, this work, is that let me show you the potential pollution sources in bathing waters, and the type of bathing water and the type of pollution. This schematic kind of gives a good overview of that. So we have urbanisation effects, we have agricultural effects, farming and so on. One that we don't think about much, waterborne transport, particularly in the sea, in terms of ships and so on. And then there are other sources, such as bathers themselves, perhaps, dogs and birds and so on. For our work, we're looking solely at this bit, in other words, the urban system. And Chris Whitty was rather keen that we looked at this, not to neglect the other sources, but just to focus our work. So in terms of methodology, then, this is what we did. There was an initial scoping workshop set up by the Royal Academy back in June last year to look at the whole issue, to see whether it was an issue, to see whether anything could be done. And we kind of got ticks all the way down that list. Yes, it is an issue, and yes, there are things that could be done. So a multidisciplinary grouping was set up. That group, which I chair, were charged with kind of getting a grip on this. What were we going to look at? How were we going to do it? What were we going to produce? And as part of that, we developed a risk-based framework, not a quantitative one, but a qualitative one. And then derived from that, we produced a whole series of what we call data cards, intervention data cards. Okay, that was the working group did that. Then we exposed those, as it were, to another workshop, and we invited all sorts of stakeholders to that workshop, not just technical experts, but people from across the board who had an interest in this area. So it's quite a lively discussion, as you can imagine. And we kind of whittled it down and honed those interventions into a group that we could take forward. We then put those interventions to industry folk and to policymakers and formulated our recommendations. Who to? Well, various stakeholders, and we'll mention that shortly. Went through another review stage. Got to be very careful and very clear what you're doing and what you're saying before you go out to the public. And then we had our formal lunch. Did I say lunch? That's a Freudian slip, isn't it? Our formal launch in May this year. So here is the health framework, and by that we assert that public health risk is at the intersection of hazard, exposure, and vulnerability. So by hazard we mean what's in the wastewater that causes harm potentially. By exposure we mean how do we come into contact with the hazard, and then by vulnerability we mean who comes into contact with the wastewater. And we see the health risk as in that intersection on that Venn diagram, at the intersection in the middle there, and there are those health risks. And we use that to frame our discussion of the various different interventions. To what extent did the interventions and how did the interventions help us to reduce that intersection point? So, what are the interventions? Well, it's that group down there. There were 16 of them that we came up with, quite a lot, but there are a lot of interventions that could potentially be used to reduce public health risk. Broadly in 4 categories, very broadly: water management, wastewater treatment, more or less, monitoring and engagement, and then maintenance and operations. So what did we do with those? So for each of those 16, we considered how to classify them. And the table on the top left there shows the risk component, the effect the intervention might have on exposure, the effect the intervention might have on hazard. We did not look at vulnerability in this work, and the reason being that we don't have sufficient information to look at vulnerability, but it could be a bit of additional work. So if we look at an overflow as a place where an intervention might take place, in terms of exposure, that would be measures to reduce the number of spills. That would reduce exposure. Or somehow to give an advance warning of a spill would reduce exposure. In terms of the hazard, are there any techniques that will reduce microorganism levels of overflows? That would go there. And then we did the same thing for effluent, in other words, sewage treatment, continuous effluent, similar things. How can we reduce exposure? How can we reduce hazard? And then we also classified each of the interventions in terms of their reduction in risk. And we did this qualitatively as a working group and then a much broader group of stakeholders. We didn't do it quantitatively. So from low right through to high. And then even more tentatively, we looked at costs, capital and operational. That one we were concerned about, because how do you compare costs? Apples and pears comes to mind, and also to what extent do we look at implementation? So in most of our output, we've done a subjective capital and operational expense scheme from low to high. We did put some numbers on it, assuming that we rolled out everything everywhere, which of course is unrealistic, but by way of comparison. But we haven't talked about that much. So that's a couple of examples of intervention cards. You won't read what they say, but one on the left is sustainable drainage as an intervention. One on the right is effluent disinfection. So they all have the same format. What is the intervention? What is the public health impact? Then a description of what the option is. Then these issues of costs, issues of risk reduction, and then what are the policy priorities of that particular technology. So we did that for all 16 interventions. And we thought, is there any way we could compare the performance of these interventions? What we did was to plot the relative risk reduction, which we'd established for each one, against the, in this case, capital expenditure to roll them out. And therefore, we could fill in that matrix, as it were, with the 16 data points. And that's okay. That's what we came up with. That's where they fitted. We didn't know where they were going to come, but that's how it turned out. We thought, well, what does that mean? We could perhaps plot a line, as it were, up the diagonal there, and you might say that that's the normal line, perhaps, and then interventions above the line might well be not very cost effective, whereas interventions below that line would be relatively cost effective. And we thought, well, what are the interventions below the line? And the two we picked out there were 11, which is risk communication. We felt that could have quite a decent risk reduction level and was relatively low cost. Number 6 there is the other one, which is effluent disinfection. Very high risk reduction, because it is an effective technology for reducing microbial levels, but really quite costly. So that was an interesting thing to do. We were just interested also in what comes out as really pricey for the benefit you get. Number 14 came out there, addressing sewer infiltration. Yeah. We could discuss that separately, but it's an interesting one, isn't it? Yeah. And we did the same thing for operational expenditure. I won't go through this one in detail, but we plotted the diagonal. We plotted, looked at what was under the line, and 7 comes out pretty well here, and that is constructed wetlands. In other words, it's used as a tertiary phase of treatment works, and possibly CSOs as well. So that was our work then, really, at looking at interventions and their relative cost effectiveness and their performance. We also came up with a series of recommendations, quite a lot of recommendations, immediate ones, opportunities for longer term change and enabling actions. I'm not going to go through all of those, there's too many, but I will pick out a few just to look at in a little bit more detail. Maintenance and rehabilitation really came on our radar quite strongly. So in terms of asset maintenance, we felt that a greater emphasis needed to be put on planned and preventative maintenance rather than just reactive. We're not saying that the industry is solely reactive, by no means are we saying that, but what we are saying is we see more potential and more benefit in more planned and preventative maintenance. We look for the industry to increase its monitoring of asset condition and operation. I'm not talking necessarily about the performance of the system, but I'm talking about the asset and the asset base. And then we see a lot of potential for exploiting new technologies. Talking to this audience, I don't need to be able to persuade you of the benefits potentially of digital twins. There they are, they're emerging, they're coming along. Are we at the UK water industry, are we at the leading edge of that? And what about all the data-centric AI techniques that are coming along? Again, this audience and us at Centre for Water Systems very strongly in the vanguard of that thinking. Asset health and rehabilitation, really, we are concerned about the degree of asset sweating that has happened in England and Wales, particularly over decades now. Asset sweating has its limits, and we've reached those limits in many cases, I think, and are, to use a phrase, chickens are coming home to roost, unfortunately. So we need a strategic and sustained effort in infrastructure rehabilitation and, if necessary, replacement. And then sewer infiltration turns up there again. Now here we're saying we need to more systematically address it. Before we were saying it's not very cost effective. And those two things don't play well together. If I had more time we could discuss it in more detail, but it's a thorny issue, that one. Think dry spills of combined sewer overflows. Next thing we talked about quite a bit in our group and in our recommendations was monitoring and forecasting. We very much support the outcomes of the Environment Act, which talk about rolling out continuous monitoring of water quality upstream and downstream of discharge points. We very much support that. We think it's a great opportunity. And on the public health side, we see potential benefits as well to test and then deploy faecal indicator organism monitors. Now, these continuous monitors for FIOs don't exist outside the lab at the minute, but they could do. And a rather nice thing about implementation of these monitors is there is a requirement to leave empty slots in the samplers where we can put new sensors in. Well, isn't this a great opportunity to be testing our new technology? We can develop soft sensors. What do I mean by a soft sensor? A soft sensor is a sensor that doesn't have a widget, a thing, but takes the data from multiple other sources to derive what we want. We want to know FIO levels, for example, and can we use some of our clever machine learning, deep reinforcement learning, so on and so forth, to come up with a soft sensor for FIOs based on what we are monitoring. And then the benefits are many, I think, of monitoring. Rapid communication, accurate forecasting, compliance, source tracing, it goes on and on. So we were very much in favour of that. Bathing water standards. Now, I talked earlier on about what they are currently. We think a comprehensive review of the bathing water standards is necessary, and we recommended that. We need to know more about, at the population level, large scale, about the links between disease and its causes. We need to establish the link between FIOs and specific pathogens, because at the moment we don't have that. What is the effective dose? What is the influence of die-off and dilution? FIOs want to live in your gut, not in the water, so they do die off relatively quickly, but how quickly and how can we incorporate that? What about pathogens from other sources? We said we're looking at the urban system, but they do obviously also come from animals. What about those? What about the validity of FIO standards for inland waters? Most of the research work has been based on coastal waters, and yet these are applied to inland waters as well. And then the whole sampling and testing regime is quite complicated. Is it sufficient? And we have a specific bathing season as well. Is that okay? Does it need extending? So lots and lots to do, we think. And then vision. We didn't want to do this report and just focus on what we were told to do, basically. In other words, we wanted to make sure what we talk about with public health fits within a much broader context of urban, catchment management, really, of the whole water system. We talk about a national conversation being required. What do we want our wastewater system to do? What do we want its relationship to be to the rest of the water system? And so on. Okay, now back to outputs from the project. Engagement, what did we do? Well, we had a launch, we had a media launch, and we got very, very good interaction on the day with the newspapers. And here are some of the headlines from the day. Top engineers urge action against human waste in rivers. That's not bad, not bad. Was that a headline? Paddling in rivers this summer could make children ill. Reducing sewage pollution must be UK public health priority, says senior official. Yeah. So they weren't bad, the headlines that we got, and we were warned beforehand, you cannot control what journalists are going to say. You can be out there, you can say what you want to say, answer the questions, and then you have to let it go. And that's what we did. The next day, a few of us did the media round, which is a new experience for me, certainly. So I went to New Broadcasting House in London. There's a picture of me on the left there sitting in a studio. I just finished the Radio 4, on Radio 4, and then I went into a studio somewhere in the building and was just waiting to do Radio 5 live. So and you can see me looking at a monitor, and on the monitor was my colleague, Professor Barbara Evans from Leeds, and she was doing BBC Breakfast on the TV. So we hit the media hard on that day, and you could see the various TV channels that took the output. So that's a lot of excitement, on the days, but where and so on. Well, we've continued with engagement, and part of the strategy was to hit the media, and then to reach more the professional and research community. On the left, there is my colleague talking to the UK River Summit, I think it was called, which was held at a similar time. Since then, I've been hawking myself around, talking about this topic. You can see me there talking at the European Wastewater Management Conference on this topic. Now, influence. You may well say, well, that's all very nice, David, but so what? So what? Well, I'm going to claim a bit of influence. I'm going to claim a bit of nearly change. How about that? And one of those is, since the publication of our report, DEFRA has instituted a bathing water standard consultation. I like to think it's as a result of our work. You could be the judge of that, maybe. But anyway, it's a consultation about seeking views from the public and stakeholders on bathing water and the standards there. And there's some details. If you are interested in that, it is still open. If you have an opinion or any expertise in this area, you can reply to that. And then, next one, influence, the vision bit of what we recommended. Again, since the publication of the report, the UK government has decided to set up an independent water commission. Now, it talks about the sector regulatory system, and that is its focus. But when you look at the 8 objectives that they have, they are quite wide-ranging about the future of water in England and Wales. It's chaired by Sir John Cunliffe, who is a retired deputy governor, is it? Yes, definitely governor of the Bank of England. So that's interesting, isn't it? So someone completely outside the sector, hopefully will lead an executive review. It's supposed to report by Q2, quarter 2 next year. So they've got to get their stuff, got to really get on with that. But I like to think that we had some influence in pushing that forward and pushing through our views about and visions for the future of the sector. So I'm about at the end then, just in terms of conclusions. When you think about it, sewers, certainly in this country, were built, started 150 odd plus years ago, were really built as a public health measure. In other words, get that horrible sewage stuff away from people, away. And that's a public health measure. Centuries later, we've kind of joined it up again. The people that we've moved it away from are now at the end of the pipe. And that's a new thing for us, and we have to deal with that into the future. And if there is one conclusion from this work I think, is to bring public health protection back into the core of wastewater engineering, actually, to have it. We've always had it in water supply engineering, it's always been front and centre, but to put it back into wastewater. And we need to align that. Obviously, it doesn't stand alone. It's got to fit in with the whole sustainability and resilience agenda. We've got to think about the costs of doing that. We've got to think whether we've got the capacity, technical capacity, for example, to do it. And we also have to think about the consumers and customers. We also have to think about who pays what and how they pay it. That wasn't part of our brief. We do think our interventions need to be based on robust evidence. We hope we've put some of the evidence in the public domain and part of this wider plan and vision. So, thank you very much indeed. Just as a post note there, I'd just like to acknowledge my colleagues who are on the working group and also the Academy policy staff who did an enormous amount of work in pulling the report together. If you want to read the report, it's online, and that's the link to it there. So, thank you very much.
Thank you very much, David. So as usual, we will start with questions from the audience here in the room, and then we'll go back to the people online. So, David, please.
David, thanks very much for the talk. I found it hugely interesting and very relevant. To some extent, this has given a bit of a blueprint for what might work, what might be less effective, or less cost effective anyway, in reducing pollution in receiving waters. Government of England and Wales has determined that we have too many sewer overflows and that there should be less sewer overflows and less damaging sewer overflows. Those two things would seem to go together. But to what extent has the regulatory regime in the UK connected with the results of this? And to what extent have the water companies that have to influence, have to make these changes, connected with these results? Are they on board with this? Are they objecting to it? Or are they just ignoring it?
There's probably quite a lot I could say in answer to that. I mean, for example, we did have water company people on the working group, for example. So, it's we didn't, and they were in all the working groups and so on, so they are aware of it. Government knows all about thinks it knows all about what the public wants. And if the public wants it, they want it, obviously, as politicians. I am a little bit concerned that the measures that are being pushed really hard, for example, as you say, reducing overflow frequencies, may or may not be the solution, give a solution to the problem that they want solving. And Chris Whitty mentioned it a little bit in you could see in one of the headlines actually, that, you know, on a summer's day, river levels are low, CSOs are not operating probably, but the treatment works is operating, and if it's not disinfecting, then the concentration of FIOs can be quite high locally. And that has not been addressed at all in the proposals, you know, future proposals. Again, I go back to what I would like to say. I would like to see public health considered in all of the interventions that are being carried out. And I know that's a big ask because they may be being carried out with other means that, you know, frankly, a rather blinkered thing, let's reduce frequency, because that's what we're going to do. But what impact will that have? And that might be something that would help with prioritisation. Because I think overflows, well, both, you know, you've got to look at where your discharge points are, where your designated waters are, and look at that accordingly. And I think we may well want in future to go beyond designated bathing areas, but to other areas, you know, sites of special scientific interest, etc., etc. And there are plans for that, I know. So it's a complicated one.
Yeah. Thank you.
Yes.
Thank you for the presentation. I really liked the matrix of costs versus benefits. I was just interested, was there any thought given to whole life costs versus risk reduction by combining OPEX and CAPEX?
No, we didn't do that in this case, but I take your point. And certainly, qualitatively, I think we could do that actually. Yeah. Thanks for that. Yeah.
While we are on this, David, may I ask? You said we didn't know what we were going to get. So, but now having produced it, what was the biggest surprise in any way?
The one that bothers me, we hinted at it, or I hinted at it already, is sewer infiltration, because I know it can be very influential in the places where it occurs. And when you look at it on this plot in particular, it doesn't do very well, does it, in terms of being cost effective. In other words, it can be very costly to deal with it. You've got to find it, and then you've got to deal with it, and then how effective is it when you've done it? And yet, you know, there's been a lot of media attention, hasn't there, of overflows operating when it's not raining, for example, and summer conditions, for example. So, but then the complication is that typically sewer infiltration will be groundwater. Groundwater will be very low, if not in FIOs. So what you're discharging is not a public health hazard. And this is where it all gets very, very complicated. So that was the one that really caught my eye, actually.
David, thank you very much for this excellent talk. Just following this, so when you look into all these interventions, how about this combination of them? Could they have better performance than individual?
Yes, thanks for that, Albert. Yes, obviously that's a big computational thing to do, isn't it, put them together. But in the text in the report, we say that quite clearly, actually, that we wouldn't see these as singular solutions. We would see them in the context of particular schemes in particular locations. And I think the other thing we would look at is, if we're looking at designated bathing waters, you have to go back to the first diagram and look at all the different sources, potential sources of pathogens, and some of the solutions required for them are not even on this graph here. So you have to look at it for what it is, but I fully agree with you, it would be combinations. Yeah. Thank you.
Okay, I think we can now go to questions online. So how do we go about that?
Yeah.
I can see Chris Newton. Would you like to ask your question?
No, we mute microphone, so we need to read out.
Just read it out.
Yeah. Okay. Shall I read it? With regard to the bathing water standards, did you also consider type of use of waters, as there is still unclear evidence of the risk of illness with swimming? And it says see more. There is still unclear evidence of the risk of illness with swimming versus bathing versus paddling.
Yeah.
Would this
Yeah.
potentially change recommendations?
Yeah, thank you, Chris, for that. We did think about that, discuss that. We feel at the moment, from what we can see in the literature and from stakeholders, the answer to your question is we don't know. And therefore, if we don't know, it's hard to make recommendations on that, or one can make blanket ones. But that's one of those reasons we felt and argued for the need to look more closely at the bathing water regulations and the science behind them. Because there's so much detail that we don't know. One of them is the one that you've identified there, Chris, in other words. What type of bathing is it? Is it paddle boarding? Is it wild swimming? Is it kayaking? What is it? And it seems unlikely, it might be that we could, a pragmatic way of distinguishing that could be for inland waters against coastal waters. That might be one way of doing it, but we're not sure. But it does need much more evidence, actually. So thanks for the question.
Okay, and then we have a question from James Rand. This may be an issue of project scope, but did you look at consequence/impact on the nature degradation rather than just impact on humans?
No, James, we didn't. It is a sort of project scope. Our brief was to look at the public health implications, but clearly, the two things overlap. And looking at ecological protection versus public health protection, many of the interventions will do both. It gets more complicated where they don't. And David's question here in the audience was about really those situations where how do we prioritise things and how do we decide which we should do? And my answer was, I think, even if we're emphasising ecological protection, I still think we ought to have in our head, let's look at the public health, or let's at least say, rule it out, that there's not going to be bathing here, or consider it if necessary. Hopefully, James, that answers that.
I just note that I was not reading the questions in the order they were posed, but
Okay.
let's try to capture as many as we can. So, Anthony Ryan, why are bathing water standards tougher for coastal waters than inland waters when dilution is likely to be much higher in coastal waters?
Yeah, Anthony, thank you for that one. When I first encountered these standards, I thought exactly the same thing. Well, that doesn't make sense, because surely in a coastal environment you've got much more turbulence, you've got more churn, you've got seawater, all of which tends to disperse pollutants and microorganisms. So shouldn't the standards be lower? But in fact, it's the other way round, that you make the standard to achieve excellent, for example, you make it higher because it's easier to achieve the lower value. So it's easier in that more turbulent environment to get that. So it's tougher. We make it tougher in the coastal environment to achieve an excellent standard. I think that's the reason.
Yeah, David, I suspect it's because the coastal environments are more used and understood.
Yes.
So
yes. Yeah. There's an element. I think there could be an element of that. Yeah, you're right. Yeah. And that is certainly true. As I hinted at, most of the evidence I've seen, most, not all, is to do with coastal environments and the health issues associated with that.
if you look at sort of seaside swimming in the UK, that's been a concept since early Victorian times.
Year dot. Yeah, exactly.
And it tends to be largely used. So you see a typical pleasure beach in the UK will have hundreds of people. Wild swimming, on the other hand, I think is a far newer pastime, and it tends to be far fewer people as well. So you may well find in a local swimming hall there might be a dozen people there, compared with the seaside.
Yes. And that is one of the issues surrounding this whole area, is to what extent it is widespread through the population. In other words, from a public health point of view, in other words, if you look at water quality from your tap in your home, that affects every single person, more or less, every single person in the UK. Bathing or recreation is, of course, optional, it's discretionary, you can decide to do it or not, and not everybody does it. And even if they do go to a beach or a river, they might walk their dog or whatever, they don't immerse and so on. So the question is, how much resource should we spend on that? And that is where we get into the politics and the debate, to what extent that should be done. And are the people using it for waters for recreation the people who pay their bill from a water company? Maybe, some of them are not. And to what extent should that be factored in? It gets all very difficult then. So in terms of this report, we didn't look at that, but we focused on what could be done and what was a sensible way forward.
I think this question about different standards for coastal and inland waters is perhaps an interesting research question that to some extent could be answered by some sort of modeling, different scenarios. Anyway, let's move on to the question coming from Joe Parker. Have you made any efforts to communicate these results to special interest groups, for example, Surface Against Sewers? Sewage, well, it says sewers. And the Open Water Sporting Alliance, apart from the general media initiative?
Thanks, Joe, for that. Yes. The chair of Surface Against Sewage came to one of our stakeholder meetings. And we heard what they wanted to say and their input to this. The chair of the Rivers Trust, I think, was there as well. So, we are talking to this wider group. We don't think we had anybody from a swimming association, whatever it's called. But we heard their voice. Obviously, again, we were at pains on those days to say, look, we're not advocating one thing or another in that sense here, but we are saying this is what we can do. This can be done. This can be done. But, the degree to which it can be done and who pays, we're not discussing today. We did get some nice quotes afterwards, Joe, from, I think it was the chair of the Rivers Trust, basically saying, well, look, we've got the top engineers in the country here saying this, get on with it.
Okay, thank you. Now, the question from Tim Malone. A lot of microbiological pollution, but what about chemical and particularly pharmaceutical pollution in discharge water?
Yes. Yeah, thanks for that question, Tim. We weren't able to assemble in the time that we had available much information on that. We acknowledged it, and you'll see in the report and probably on a slide somewhere, that there are many other potential issues coming along the line. You mentioned some of the chemicals, the micropollutants, the pharmaceuticals, and other things. Microplastics is another one. Now, obviously, they have ecological implications, but they also potentially have public health implications. And I think that's another sector, another group really needs to have a look at that one as well. We were pressed by the chief medical officer to look at fecal oral infections because he sees that as the most urgent and direct area that needs looking at in detail.
That was the exam question.
That was the exam question.
Okay, and then we have...
And the teacher said he was pleased with our analysis.
That's fine. Yes, we have a question from Ian Barker. Great presentation, David. Given what you've learned from this study, what other aspects of water supply and sanitation do you think would benefit from a similarly intense and cross-cutting review by a diverse group of experts?
Thank you for that one, Ian. You could see at least two kind of mirror studies, as it were. One would be, okay, that's the public health on the wastewater side of things. What about the ecology on the wastewater side of things? And to what extent do they overlap? We've been talking about that. And then the other one would be on the water supply side of things and water distribution, looking at those issues. In this part of the world, we had a cryptosporidium outbreak very recently. We know these occur sporadically now and again, and to what extent is that an issue? And I think another really interesting area that we haven't really got yet is to what extent does wastewater pollution control provide a public health measure for water supply? In other words, if we reduce contamination of our rivers where we're taking water from, what influence does that have on the water treatment processes and so on, particularly when it comes to the more exotic things, pharmaceuticals, for example, we're talking about. So I could see at least two or maybe possibly three other parallel studies. Ian, if you'd like to do one of them.
Jim Marshall, will you be submitting this excellent work into the Cunliffe Review? And in reality, contamination in the wild is a mixture of wastewater, treated or otherwise, plus urban farming and road. What are the impacts of this mixture?
Yeah. So in terms of the Cunliffe thing, we're going to be discussing that very shortly as a working group, how we're going to interact with that, the Water Commission. So don't know yet, but we'll definitely get our voice heard. We're also submitting evidence to the Bathing Water Regulation consultation. That's in process at the minute. The other one was, just remind me about the other bit, was the...
Farming and high
Yes, yeah. That kind of relates back to the original diagram that I showed in terms of scope, actually. That one there. They're all there. It is a matter of scope. We thought to make this thing tractable and to really look at human pathogens, or the biggest source of human pathogens, we would home in on the urban systems. But that doesn't mean to say, if you're looking at bathing water designation, that the other areas are not important, and they are important. So maybe that's another parallel study that needs to be carried out to look at the influence of these other sources of pollution. And I would guess that each bathing water has a different mix of those, actually, which is a very important thing. I think also making a link between designating a bathing water, remembering, designating it, doesn't make the water quality good or excellent. It just means we are measuring it and we're going to put a sign up, crudely. Then there has to be this link to get back to do something to make change. And that change can be part of the urban system, but it can also be part of farming practice, agricultural practices as well, and indeed some of these other sources. So, yeah, hopefully that answered that.
Okay, we have 1 minute left, so go for it. Okay, go
I
for
was
it.
getting the last minute. Road runoff.
Yes.
So Jo Bradley, friend of mine.
Yes.
She argues everyone's ignoring it, and it's toxic,
Yes.
and it causes the fish to swim more slowly, not catch their prey, breed less.
Yes.
And she says get the aquatic environment right, and it's safe to swim. But at the very least, we need to know what's in the road runoff, and putting the sensors on the CSOs will tell us a certain amount, but maybe the problem is elsewhere.
Yes, I suspect that from a public health point of view, that it is not such an issue, actually.
Unless it's carcinogenic.
Unless it's carcinogenic. But carcinogenic usually means long-term exposure and long-term ingestion. So I think we go for the low-hanging fruit first. I wouldn't make that statement about ecological protection, because I think road runoff, Jo and I have talked about this as well over time. It's an extremely important issue, and she's championed it really, really well. And it is a big issue. But I still think from a public health point of view, let's go for the fecal oral to start with, and then look at these other ones in another parallel study over time.
I will say just one sentence at the end. I think this presentation and the discussion